Let's take a look at target 34, sketching the polynomials given a factored form of the equation. You guys, this is kind of fun. Once you get the hang of this, this is a pretty good activity. So we're sketching the polynomials. The polynomials are those roller coaster kind of shapes, so I get to sketch it. Well, some things you want to look at is, where are the roots? Well, the root of this means that this is going to hit at 1, so I just go down here and put a dot at 1. This one's going to hit at -2, so I put a dot at -2. Remember, it's that whole opposite trick when you do these, because basically what you're doing is you're setting each of these equal to 0. When does this equal 0? When does that equal 0? Well, this would be 4. 1, 2, 3, 4, and I put a dot there. 1, 2, 3, 4. Whoops. I put it at 5 because I put it 4 over from the other one. My fault. What I'm going to do is I'm going to cancel that one, get that one out of there. Okay, so now this is what it is. So now it's going to parabola. What I usually do next after writing down the roots is I put what it's going to do there. This is going to parabola here. It's going to make a line through there. It's going to make a line through there. So then once I've figured out where the roots are, the x-intercepts, and I've figured out what they're going to do at that point, then I start graphing. The key is to always put your last arrow on first. Where is that ending arrow? Well, that ending arrow is based on if this is a positive or negative graph. Well, there is no positive or negative number out here. That means it's positive. So the last arrow is going to be up over here because this is a positive graph. All right, next, if I were to multiply this out, I would have x squared, x and x. That's 4 powers of x. 4 powers of x, or being a 4th degree polynomial, is even. And if it's an even power, then both arrows are together as in even. If it's odd, the arrows are opposite, and I would have put the other arrow down here. Even power, it's going to be even. Those arrows are together. And then it's kind of fun. I can just go through and make what it's going to do. So it's going to come down. It's going to parabola on 1, which is here. So I need to be aware of that. It's making a line through -2. So -2 is a line. So I'm going to have this thing go down. And at -2, which is right here, it has to make a line. So I have it go down and make a line. And then it's got to do a parabola at 1. It just so happens that this is going to be an upside down parabola so that it can also make a line over here and end with that up arrow. Okay, and that's what the picture is going to look like. Now, I usually would say that there is a 3-step process here. Step 1 is mark the x-intercepts. The x-intercepts, mark the x-intercepts or the roots. Then the second step would be to do the last arrow. Do the last arrow first, and that last arrow is based on, do you have a positive or a negative number out front? Positive numbers go up, negative numbers point down. And then the last thing to do before you actually get to draw it is look and see if you have an odd or an even power for your first arrow. So the odd powers are going to be opposites, so odd, opposite, and even together. So when you graph an odd, the arrows do something like that where they're opposite direction. When you graph an even, they do whatever they want, but they end up both in the same direction. So once you've made that determination of the odd and even and the positives and negatives, and you've marked your x-intercepts, then that's where you use the thinking of what is it doing at that point. It's paraboling or line. So you make it do that. This thing made a line right here. It cut right through. It made a parabola right there. It made a line right there. And you can see that happening as you go through the graphs.